Hello, and welcome to another session. This time around, I want to build a interesting topic to me in Rust, and it's going to be a simple decision rule engine, really inspired by Camunda and similar engines like that. So, in short, there's a possibility to come up with a configuration in the graph view, which would start with some task initiation thing, then some action should be performed by a person or by a timer, and then we go into a table, a DMN table, decision model and notation thing, which will give you another output, and the logic will branch off until some logical conclusion is met. So I want to concentrate on DMN part, the table part, which is actually Excel-like. You have some whatever rule accumulation principle, which I'm not gonna touch for now. You've got some inputs, and you've got the output section. And whatever you input here is gonna determine with AND operator kind of thing into this. So if some input is equal to whatever here, and this input is equal to whatever is here, and this input is equal to whatever here on the line, and this, then it's going to give you this. Obviously, Camunda has complicated structures and even a sub language behind this stuff. You see there's like list contains functionality in there, but this is too hard. And what I want to concentrate is another thing that I found fascinating on the internet. Some person, Chef Van Leuven, I'm sorry if I mispronounce you, um, made a cool demonstration where the person created a similar table with some variables as the header and values in the rows that would eventually end up as a execution output. So here you see some rules were applied, and if they followed through, like if the logic actually happened, then the output is highlighted in a interesting manner. This is my main inspiration point. I want to build something. Oh, now there's more outputs. I want to build a simple Markdown file and read simple rules in here just to give you a set of outputs. So we're gonna build a Markdown table reader. And with that, um, let's get started. So I've created a simple, basic uh, Rust project. All it does is just outputs hello world, as you see. I also just created a samples directory and empty table md, which will have our markdown for the table. Obviously, I'm not going to create a table from scratch. I'm going to copy paste whatever I find on the internet. And what I find on the internet is, well, this. So on a bunch of websites, let me show it like this. There's a ton of examples, and as you see, um, Markdown like this will end up as a HTML, content cell, content cell. So this is cool and defines the rules for us to follow. I like this rule that we can have a leading and trailing pipe symbol just identifies the borders of our table, and actually this is more readable to me than this, because you have to imagine the table borders, and I like to restrict the field view for myself where to look for the symbols. So this is inspiration thing, and yeah, I'm literally going to copy paste the contents of this table here because I know how it looks like in here, and bam, I've got my table. So yeah, write it. What I like about Emacs, apparently, well, this is Emacs. Um, it allows some cool features like editing for Markdown. If I add stuff in here, whatever nonsense, and then I press tab, it auto formats stuff for me. I can just navigate wherever I want. Shift tab will also give me a possibility to step back. I didn't know that. That's a cool find for me. Let's remove this nonsense. So at least with Emacs's validation thing, I know that this table is correctly aligned with the rules for MD format. So yeah. So this is done, and yeah, let's close that. Whoops, no. So now we need to read that file into memory in order to parse it. We are not going to use any Markdown or whatever package to do this for us. We are actually going to read a string from a file into memory here and parse it character by character. Is the easiest way and the more interesting way. So I've already done it when I was trying to rewrite Python, somebody's Python code on the internet uh, into Rust. It's my Rust.fl lang. Actually, I'm gonna add this to my show notes. Um, Rust.fl. So I was trying to have a simple Lexer, like reading a code thing and executing that in Rust. And the feel language is actually something that DMN uses as well and the entire Camunda thing uses feel language to let their customers have some custom logic. But this is my test of actually parsing the code. So I know for a fact that I want to read contents of a file, and since this is a reusable code, I can copy paste it. Yep. Bam. Oh no. Command V. And I actually have to check how to read contents from a local. I'm not going to make it a parameter. I'm gonna straight up read it from samples folder. Samples folder table MD. So this is where I usually develop. I don't write code like on my own from memory. Memory is a limited actually, and this is my seventh language that I'm learning, and I don't have the capacity in my brain to undeclared. I don't have the capacity in my brain to remember every command and structure, so I just know where to copy paste stuff from, especially if I've done it. So cool, it's been read, and yeah, let's actually print it out. Len this contents. All right, cool. So it was able to read contents, and we are outputting that. So in my example thing, I passed the contents into a lexer, longer lexer. So it fed data into lexer struct, and then the thing was tokenizing it. So I don't want to create structures like here. I would just want to straight up read the stuff I'm interested in, like from main, and just see what can I do. Um, so I'm gonna work with this immediately. I'm going to rewrite it for a character in contents chars. So it does this, and let's actually do the same thing. If L equals 2, I'm interested in a pipe. Okay, I want to work on identifying whether I should create a line or a cell of a line. Okay, and I'm going to print. I never used print, just print line. Yep. So how many times do I see line right now? Whoop. A local variable with similar already. Oh. C. It should be C, not L. It didn't read it? Oh yeah, it read everything. It found many lines. So yeah, at this point we know for a fact when we found a line. What's important with Markdown, when it sees it's on a new line, it's not a line, sorry. I'm going away, like I'm going ahead of myself. So we found a pipe, and I want to keep track if we are on a new line, because Markdown always looks at the fact that we are on a new line and it should become a row. So it's a new line. And it's true. So we found this. It's found a pipe, and maybe here, if we are on a new line, oh, we don't need to use that. If new line, then print ln. Yeah, println will work to identify in the terminal, like it will go to new line as well. So we are, actually I'm going to message that we're in a new row, and then we found a pipe. So it's going to say that we are on a new row once at this point. Pipe, new row. Oh yeah, now I set it to false. So new line equals false. Let's do it again. Whoop, cannot assign twice, immutable. Yeah, it needs to be mutable. Mute. See, the reason I'm working with simple parser and literally reading characters is because it's like down to the core um, logic stuff. Usually when you see tutorials, it's all about how people assemble different complicated systems together, making HTTP requests, and you just get lost in many frameworks, and you're trying to find where Lego pieces combine. But I don't like combining stuff. I like just working with raw data and maybe working out data flow. And this is data flow. We've got our data and we have to flow it in the correct order. This is interesting, way more interesting than connecting AWS the functions, serverless functions to whatever thing. Why bother? All right, so and apparently this is the new line. Oh no, this is string stuff. Yes, this is the new line. So whenever we find if C is equal to, oh come on, a new line character, then we set new line to true, and we're not interested in anything anymore during this step. Well, maybe we will close whatever thing we will create based on the states we're in, but at this point it's just we are reading the board boundaries where we want to create stuff later. So we've done that, and we should have several. So new row, we've got pipe 1, 2, 3, 4. 1, 2, 3, 4, 4 pipes. Nice. So we were able to be here. Um, yeah, maybe instead of pipe, we just output the pipe. This is interesting. So 1, 2, 3, 4, new row. 1, 2, 3, 4, new row. Nice. So we have this in front of us. What we need to do right now is once we find a pipe, we know that we want to assemble all the characters that were before the next pipe. because eventually we will accumulate these into some sort of structure, let's say a cell. We don't have a cell yet, but we know that we can accumulate the string. And again, if you can copy stuff from somewhere, then you are a good developer. If you know where to copy your code from, then you can create something extraordinary, like a new extraordinary thing. So I've got a TMP of a string, and I need a string because I will be appending to it. So I need a string on the heap to be able to append to it. If I had just a slice, then I would not be able to append to it. All right. So this is the thing. So what do I do? So apparently, whenever I find a new line, a new pipe, when I find a new pipe, I need to clear my temporary string where I assemble these things. And the way we do that, we clear the string with clear. So tmp clear. So we clear that. We will have to do something with the string after we decide where to put it, but for now we just clear. A new line, we don't care about new line. The clearing of a TMP will be done by next pipe. The new line will mean something else. New line will mean something else. Yeah. What I will need to do next is, oh, I guess I can straight up skip to the next iteration of the thing. Continue. I learned how to do continue just on that rewriting somebody's Python code into Rust. Continue. All right. Does it still work? Yes. All right. So we managed to avoid this now, and we checked for these now, and we know for a fact that we can push. We can start assembling the characters that we read into temporary buffer. So I know for a fact that in TMP I can push the character. So we have our character, and that's pretty much it. So now when this is here, we output the new row. All right, that's fine. I'm going to print everything I had in the TMP up until this point. So I'm going to output TMP and I'm going to push that up because it's cleared and I would see nothing. So we output this. We output this. We output the temporary thing we assembled. We draw a pipe. We don't draw this D word. So this is just going to new line. So we assembled it here. Nice. I wonder why it added a bunch of these. Oh, because it came here and it still added stuff here. I will make this a match afterwards. Yeah. After this, we continue. All right. Cool. So we have the same content we had, character by character. Yeah, let's have a little fun and maybe add a different symbol so it stands out slightly that this is just a copy. So yeah, we've got a lot of bangs here. Cool. So this is nice. And now I want to create a basic struct with like a table struct with just rows. A table struct which will contain rows. So what is a row? So how was I going to implement structs? Oh yeah. So a struct, uh, let's create rows first. Row, row. A row is just a collection. A row is a collection of cells. So I need to have cells. They are going to be, oh yeah, this is a vector of strings. I literally have something similar to this. A vec of strings for now. It's going to be a vector of strings for now. String. All right. So this is a row collection of. I am going to implement some functions with the row. So let's keep that as this. And we need a table. And it's going to be a collection of rows. I'm not sure if I need to do that, but I am exploring. I don't have my mind already set up. I don't have a I don't have a layout plan to do this. I just read whatever could be read into whatever I can understand. A concept of a table, a concept of a row. Cell for now is going to be a string, but technically it could be anything afterwards. All right. So I know for a fact that I want to have a table. I want to have let table. No, not table. Of a type table is going to be table rows, just a vector of was it like this? All right, I'll have to trust the compiler. I forgot the semicolon. Did I write it or just pressed on a random key? Nice. So still works. So at this point, when the new line, no, let's not skip ahead. So we are on a new line. A new line. So this is a case where I'm struggling a bit. I know I will have some mutability and ownership issues because I am assembling a pretty much array of arrays, and I'll need to understand how to deal with that. So when we find a new line symbol, whatever row thing we have, we should push it to whatever table we have. Oh yeah. Maybe at this point I should create let row. This is going to be a mutable row of a row type specifically, and row is going to be cell. Did I define it like this? Cells. Cells is going to be vector bang empty. And the same issue again, I didn't put the semicolon, and Rust thought that this is a return statement and it throws me an error. Alright, so we've got the row, and for now it's not complaining about anything. Nice. All right. At this point, we don't know if we should create a new row or not. Oh yeah, when we find a new row, so this is the case. Oh, why am I finding that here? When we are on the very first thing, when we find the pipe, it should create a new row. At this point, it's already defined, but yeah, maybe whenever we go to new line, we don't care about the contents of the row structure. We need to create a new row when we find a new pipe and we are on a new line. So this is the place where I also rewrite the contents of a row. This is completely wrong, I get it, but I am coming up with a solution on the spot. And whenever we found a character that we are on a new line, we need to push whatever row we have into a table. Push, or was it append? I think it's push row. It's going to be empty array for now, the row, but at least we'll have 1, 2, 3, 4 lines in table. Did I write it? Crap, method not found in table. Because table is not an array, it contains rows. Yes. Oh yeah, and I think table is, yeah, it's not mutable at this moment, and it would throw me an error. So it's mutable now, and oh shit, a row, but I did edit a row. Oh. It's not a vector of strings, it should be a vector of rows. Is it going to throw an error because the struct row is defined below it? Or does it keep in mind that we have it in general? Alright. A copy trait is not added to it. Reinitialization might get skipped. Value moved here in previous iteration of the loop. So this is an interesting topic I'm looking at. So line 23, it says move occurs because row has type row, which does not implement copy. And this reinitialization might get skipped, and the move is in the previous iteration. How do I make it work? On the line 40, it knows I'm doing something weird. Should I box it or something? Should I box it? Yeah, I just don't know. Maybe it's ownership stuff. So I'm gonna investigate that. Mm, Before I quit, maybe let's look at this portion I've done here. I'm trying to use a row as a temporary thing like here, but I don't think it's correct. I mean, I'm creating a row here and I expect it to live actually like to make it all the way here. Feels weird. So I guess this is not correct, right? Um, we are creating something whenever we got to a new row already. I'm going to try this last thing. So I want to immediately push this. I'm going to use a local thing here. I will add this here. Maybe from this point forward, I'm not going to immediately interact with this thing. Yeah, let me try that first. Oh, come on. Did I write it? So yeah, I'm adding a row, which is an empty row. And this, it should be a reference. It should be a reference to a row that we are adding to this. I think it should be an option. It should be reference to a row, and it's going to be none first. Will it compile? Still compiles, and yeah, let's do row equals to sum underscore row. Like this. Still works. So All right, so at least we've got a row in the table. We're not stealing from a table. I mean, the data is stored in a table array deep inside there, and it's not living too short. I mean, it lives long enough for the reference thing to be alive. Actually, let's print out the last thing just to see what we accumulated in table row. No, not table row, just table. Table. Tabler. All right, table. I'm quite sure it's going to be yelling about ownership of table now. Shit. Cannot be formatted with a default formatter. Alright, where is the helper? Oh, maybe I can just do this. Oh boy, let's finish this faster. Yeah, derive debug. So I'm going to finish right after I apply debug information to this and this, because this is becoming mentally taxing, and I will carry on probably in several hours when I relax. Well, at least this is good. We've got a bunch of rows. A row 1, 2, 3. We've got 4 empty rows, which corresponds to 1, 2, 3, 4. We've got our setup done. We'll continue next with feeding the strings inside here to the cells array so that we get 1, 2, 3. 3 cells for every row. Thank you so much for your attention. Till next time.